One of the types of numbers that we're going to be getting into here are numbers that are known as rational. And if anything can exist in math, we've talked about the opposites of it. So we're going to talk about rational numbers and their opposites. So the goal for today is I can determine if a number is rational or irrational. Now, when you think about the word rational, the word rational means that something is based in logic or reason, basically meaning it makes sense. It's understandable. You can comprehend it. So many numbers that you're familiar with are rational. And what rational means in a math sense is that it can be written as a ratio, which is a fraction. So let's just look at some examples. Here we have 14, right? So 14 is 14 over 1 in some instances, or in other instances, it's 28 over 2. There's actually an infinite amount of ways you could take this number and write it as a fraction. Same thing is true for a number with like a simple decimal, right? Like 2.5. So 2.5 is 25 over 10, or it's 2.5 over 1. There's tons of ways to write this, an infinite amount of ways to write this as a fraction. Even a repeating decimal, right? Like 0.3333, and 3 goes on for forever. Even though there's that forever part of it, it's predictable. Once you get to the 100th 3, what's going to come after that is going to be 3, and then after that is 3, and you kind of just know where it's going. In fact, 0.3 repeated is famously 1.3. So numbers that are predictable, numbers that make sense, and numbers that are understandable are all rational numbers. But there are the opposites, right? There are the not rational numbers, aka the irrational numbers. So irrational numbers are numbers that are not rational. They're written as a decimal. They go on for infinity. They never stop, and they don't follow a pattern. And one of the most famous examples is the square root of 2. And in fact, if you don't believe me, if you think that, yeah, I can write this as a decimal, maybe you go to Desmos and you type in, the square root of 2, which would be 2 to the 1/2 power, and you get this, right? And you're like, okay, I don't think this is forever, right? It seems to stop here. Well, actually, here's a website from NASA, and they have the 1 million digits of the square root of 2. In fact, they say that, based on our computers, we have checked to see if there's a pattern here, and there's no pattern, and it goes on. So 1.142, and then just look at this. Ready? This goes on and on and on and on, and it does not have any indication of stopping. And you better believe there's no pattern here. So, or at least there's no pattern that we can see. So square root of 2 is irrational. So more examples of irrational. Should have written irrational there. I guess I wasn't being rational myself. Are numbers like this, like square root of 10, square root of 64. And pi is a very famous example, right? 3.1415926, and it repeats forever. There are an infinite amount of digits to pi. The same thing is true when you do square root of 10 or square root of 64. All of these numbers do not stop. There is no observable pattern, and they do not make sense. And a big indicator is if there's a square root, the number is irrational.